Alright, hello people, how y'all doing? I'm gonna go over the last unit for calculus, and don't expect this to be the perfect lecture because I'm doing it on the spot. Um, but anyways, let's head right into it. So what the last unit says is, well, we have, remember, with geometric sequences or series, we did some test that was something like I believe it was like plus AR n minus 1, or well, AR plus AR squared plus AR cubed, so on. And the way you would notice it is if it was AR n minus 1, right? If you see this, if your sum was n equals 1 and you saw this, then this would be geometric. And if the sum was n equals 0 and your A was ARn, this would also, this is not n, this is r, and this was also geometric. Now, there's obviously other ways that we can get our convergence test, like see if it converges or not. And that is if you take your A of n and, well, you take your A of n plus 1 and you divide it by A of n. Then you take your limit of n. If whatever you get from this operation is less than 1, converge it. If it's more than 1, diverge it. If it's 1, it's inconclusive, right? And so when we're going here, obviously we want to do, you want to check, and you turn this into geometric series. Obviously turn it into either n when this is 0, but this is not 0, so you need a r n minus 1. Can I turn this? Maybe you could in some other world, but just looking at it, that looks too complicated. Right away, ratio test. How do you do the ratio test? You do an plus 1, so whatever you see n, do plus 1. That's literally all you do. Whatever you see n, do plus 1. And this would be n plus 1, right? Plus 3 to the 4. Now what this will turn into is negative 1 n plus 1 all over n plus 4 to the power 4, right? Now what you want to do is divide by the bottom. This is not given, by the way, so do know this. Then you divide by the bottom, which is just a to the n. What's your a to the n? It's this one right here, what it is. And so what you do, all right, sorry, y'all useless pass later called me. But anyways, all right, so what you do now, obviously this is your n plus 1. And so what you want to do is obviously divide it by your an. And so when you divide it, oops, let me just delete this part. I'll just rewrite this. And so what you do is obviously divide it by your an. An is just this. This is just your an. It's just the regular function. And so you just write it as it is. With your ratio test, you will always flip and multiply, almost always. Because this division, what you want to do is flip. You can flip this, make it n plus 3 to the power 4 over negative 1 to the n. And then your sign turns from division to multiplication, right? And so doing that, when you do that, what you'll get is obviously your 1n minus 1, plus 1 over your n plus 4 to the 4, right? Now what you do is, well, technically you can just combine this, so you'll get minus 1 n plus 1 all over n plus 4. And I'll show you an even faster way to do this. By the way, do know the one you flip is always your an. Your an is always the one you flip. Why? Because your function is n plus 1 divided by your an. You only flip and multiply the bottom. So if the bottom wasn't an, let's say it was like x over 2. When I rewrite this, it'll be 2 an plus 1, right? Well, let me make my a bigger so it doesn't look like a subscript, over x. So you see, you only flip the bottom. You always flip the bottom. And so that's why you only flip your an and you don't flip your an plus 1. Okay? And so now when you got this, you just cancel shit out. And so you see your n, when I do n negative 1, when I do n negative 1, n plus 1 over negative 1 to the n, this is the same thing as saying negative 1, n plus 1 minus n, which is the same thing as n plus 1 minus n. And these two cancel out. So I only get negative 1 to the plus 1, right? And so this, the whole thing will turn just negative 1. So this will go away. This n will go away. I'll get negative 1 to the 1. But as you can see, I'm taking the absolute. So this negative 1 doesn't do anything because I'm taking the absolute anyway. So it just all goes away. And so I'll get is n plus 3 to the 4 and n plus 4 to the 4. Now, since both of these are raised to the 4, you can rewrite it to n plus 3 over n plus 4 all to the 4. Okay? And so now you can take your limit. And the way you take your limit here, so you know how, don't forget your limit, right? That's what's up here. And so the way you take it here, you just divide everything by n. So let's divide this by n, divide this by n, divide this by n, and divide this by n. And so once I do this, what I'll get is n over n is 1 plus 3 over n. And then I get n over n is 1 plus 4 over n. Now, I still have this. Nothing has changed. I just divided everything by n. Why did I do that? It's so I can take the limit. If I take the limit here, my denominator will go to infinity. My numerator will also go to infinity. So I'll get infinity over infinity. And you can use L'Hopital's rule here. But obviously, an easier way would just divide everything by n. Well, not by n. So if this was n squared, I'll divide everything by n squared. So it's the denominator's highest power. All right. So the denominator's highest power, whatever the highest power of the denominator, you divide by it. And so anyways, once you get that, this is what you get. Now you can take the limit. Anything over infinity is 0. Because if you divide 1 over 10 and 1 over 1,000, as you can see, as this number gets bigger, the whole thing goes like very small. And so that's how we know it goes to 0, right? And so now when I take the limit, this goes to 0 because it's a number divided by infinity. This goes to the 0, number divided by infinity. I'll get 1 over 1 to the 4, which is just 1, right? And if we go up here, if our limit equals 1, the ratio test is inconclusive. So our function, or our limit, is inconclusive. You continue the word. All right, going down here, same thing again. Can you get this to the n minus 1 for geometric? Too hard. I don't know how to. So I'll just go ratio right away. And so what I'll do is 7. This is the fastest way. The fastest way is write your 7n plus 1. So 7n plus 1 divided by n plus 1 factorial. Remember, I'm doing n plus 1. So my factorial, I'll have to put it in brackets. Okay? And so now when I get this, what I can do is the flip and multiply all in one step. I know I'll have to divide by this, and I know I'll have to flip and multiply. So what you can do is just take the denominator, put it in the numerator, and take the numerator, put it in the denominator. And so what I'll get is n factorial times 7n. That's really how it goes. Yeah, I just flipped and I plugged them in. All right, multiplied. All right, and so now when I get this, cancel things out. So 7n cancels with the n. We explained up with the 1. All right, now what I get here is I'll get 7 at the top, n factorial, and here I'll get n plus 1 factorial. And so when I got this, my n plus 1 can be rewritten. My n plus 1 factorial can be rewritten to n plus 1 n factorial. That's one way to write it. If I had n plus 2 factorial, what I'll get is n plus 2. This is another way to rewrite it, by the way. They both mean the same thing. These two, this one is equals with n plus 1. All right. Oh, sorry, no. Yeah, n plus 1. All right. If I get n plus 2 factorial like this equals to n plus 2 times n plus 1. You like go downwards a little bit. Plus n factorial. Now, if I got 2n plus 2, this will equal factorial. This will equal 2n plus 2 times 2n plus 1 times 2n factorial. All right? Or I believe like it goes 2n factorial, something like that. All right? And so that's basically, so I can basically take this and rewrite it at 7n factorial all over n plus 1 n factorial. And now I got these two cancel out. I'll get 7 over n plus 1. Now I still got to take my limit, right? And so when I take my limit here, my denominator, this goes, well, this whole thing, I got 7 over infinity. So this whole thing will go to 0. And so since I got 0, if I go back to the rules, 0 is less than 1, therefore is absolutely convergent. All right. Going next here, this is a little bit harder, but you can basically use the same rule, which is your ratio. Now we got 1 n plus 1. And then I got 2. Remember, this is 2n. So this is n plus 1. You only want to take whatever your n is, put a bracket around it, do a plus 1 in there. So this is not 2n plus 1. This is 2n plus 1. The difference here is when you FOIL this in, you get 2n plus 2. You see, this and this is two different things. All right? And so this is 2 times n plus 1. All factorial, all over. And I'll make this longer. There you go. All over 6, 5n plus 1. And this is n plus 1 plus another 1, right? And so I get n plus 2, right? And so after this, what I got is, obviously, remember, put this at the denominator, put this in the numerator. So then what I got is 6, 5n plus 1. And in the bottom, I got negative 1n, 2n factorial. Now when I do this, well, what cancels out? Let's see. My 6 and my 6 cancel out. This and this cancel out. I get negative 1. I'm taking the absolute, so the whole thing goes out now. So let me rewrite. I'm going to FOIL my 2n. So I'll get 2n plus 2 whole factorial 5n plus 1, right? All over 5n plus 2. And I got 2n factorial. And so what you can do here is this 5n will cancel out, this n will cancel out with this n, right? Because what I'm doing here, when you divide, you're doing n plus 1 minus n plus 2, because they're the same base. So I could do this. When you divide them, it's just like x over x. What I'm doing is x1 minus 1, and I get x0, which is just 1, right? And so when I do this, FOIL my negative, so I'll get negative plus 1 minus n minus 2. And so what I'll get is this will go out with this, and my 1 plus I get negative 1, right? But obviously, negative 1, this is 5 to the negative 1, which is 1 over 5. You see what I mean? And so what I'm going to do here, I just cancel out my n's. And remember, there's a 1 here. So I do 1 minus 2, that's just 1, which is 1 over 5. And so 2n plus 2 factorial. Remember, this n canceled out with this. This 2 minus 1 is 1. So I still have a 5 to the 1 here. This is divided by 5. Oops. 5 to the 1. I'm not going to write the 1. And then I got 2n. Remember up here I just explained how to do this? This one can be rewritten as 2n plus 2. 2n plus 1. 2n factorial. All over 5 2n factorial. These cancel out. Now I'm going to rewrite it here. 2n plus 1 or plus 2. 2n plus 1 all over 1 over 5. And so what I can do here, I can take the 1 over 5 outside my limit. So I'll get 1 over 5. Limit as n goes to infinity. 2n plus 2. 2n plus 1. As you can see, this whole thing goes to 0. It goes to infinity. So now I got 1 over 5 times infinity, which just means infinity. And as you can see here, if L is more than 1, it's divergent. And so this is divergent. All right. Now the second thing is the root test. What is the root test? Now your thing is the same as your ratio, where if your number is less than 1, convergent. If it's more than 1, divergent. If it's 1, inconclusive. And so if I go to my lesson, where is the lesson? Oh, there it is. Okay. So if I do the root test, basically what the root test says is that if you have the whole thing raised to an n, you can take that bitch out. So what I can do, I could root it by 1 over n. And so I get 6. Let me make this thicker. I'll get 6e to the negative n plus 1. I'm just rewriting it to the 4n. And what I'm going to do is I'm going to root it by n. Now, what does this mean? If you rewrite the root, this means the same thing for n, but then my root, what it becomes is 1 over n, right? So usually if you do like a root x, this is x to the 1, 2, because there's a little 2 here. If you do root 3x, this becomes x to the 1 over 3. So since we have n, our result is 1 over n. Okay, now why are we doing this? It's because now we can cancel out that exponent. This relationship here is just 4n times 1 over n. And so if I rewrite this, 4n times 1 over n is just 4n over n. And you see now these two cancel out, I just get a 4. Now I can take my limits, and so what I get is 6 over, this negative n means e to the n plus 1 to the 4. Now the limit, remember, e to the n is a very big number. If you do e to the 1,000, you'll get an error, and that's okay. But if you watch, if you do e to the 10 and you do e to the 100, you'll see the number gets very big. And the reason you get an error is just because your calculator can't handle it. But this is actually a very big number. And so a number over infinity is 0. What I get is just 1, 4, and that's just 1. And remember, when your L equals 1, it's inconclusive. And so this is inconclusive. All right. Now doing it again, you see this whole thing now to the n. Let's root it. And the quick way to do it is as soon as you see n, and you don't forget this 9 here, and as soon as you root it to the n, this is just you multiplying this by 1 over n. And this will always cancel out. Well, leaving you with 1 technically, but so you can, as soon as you see this, you're like, you know what, root. So what I'll do is you'll be like, wait, but not the whole thing is over n. Look at this. But remember, when I'm doing this, limit as n goes to infinity of 9 to n plus 1 all over 3n plus 4 to the n, I can take this 9 out. I can take this 9 outside the limit because there's no n with it. So what am I taking the limit for? A 9? I can just take this out. And so now here I can do the root, right? Which means I'm doing 1 over n, which means these two cancel out. I got 2n plus 1 over 3n plus 4. Now when you take your limit, before you take your limit, obviously this is infinity over infinity. And so what you'll do is divide everything by the highest power in the denominator, and that's just n. And so what I'll do is 2n divided by n plus 1 divided by n over 3n divided by n plus 4 divided by n, and then take my limit. Obviously I got a 9 here. And so as you can see, this goes to 0 now. This goes to 0. These two n's cancel out. These two n's cancel out. What I get is 9 times 2 over 3. And 2 over 3, well, I'll just do it for fuck's sakes. 2 over 3 times 9. Oh, that's 6. Oh, I could have just done that. That's 18 over 3. Okay, whatever. Lol. I got 6. 6 is bigger than 1. Therefore, divergent. Alright. And moving down, power series. What is a power series? Power series is actually pretty simple. Don't let it scare you away. What power series says, well, this is your equation. You have c, which is a constant number, and then this is the format. X minus a to the power something increments, right? And so here, it's centered at a. My a is 6. But here you see this is a plus. My equation is a minus. So when my a went in, this must have been x minus 9 for it to get an x plus 9. And so my a is negative 9. All right? And so now when looking at this, I want to see if it converges or diverges. First thing you want to look at is, do I use root? Just the first thing you want to look at is, imagine this as just a number, 1, whatever. Do you use root or do you use ratio? Now root has to be the whole thing to the n. But that's not the case, only the x's. But I can do ratio. Ratio is what? N plus 1 factorial x over n plus 1 divided by, right? Well, here you just divide it by, well, I guess I don't have a big division. I don't flip and multiply here. So I just write this in. Remember how we said 1 goes to the numerator, 1 goes to the denominator? But here there's no division. We were doing that when we had a division. But here is not division. So you just divide by your a to the n, which is this. And so here you see this cancels out with this n. What I'll get here is n plus 1 x, right? I just canceled out the n's, but the 1 is still here, so I have an x left. At the bottom, I got an n factorial. Remember, n plus 1 factorial can be rewritten as n plus 1 n factorial, right? And so if I rewrite this, right? Now these two cancel out. I got n plus 1. And now this is the difference between a power series. When you get to here, obviously, let me rewrite my limit. So I have a limit as n goes to infinity. Now I got n plus 1 x. Now when you're doing this, you can take your x out. Remember, it's just a number. But don't forget, we're taking the absolute. Remember up here? Where is it? Oh, there it is. You see, it's the absolute. And so when we're taking an x out of the limit, we absolute it before we take it out. And so this is x, limit as n goes to infinity of n plus 1. Now I can take my limit. This is the absolute of x times infinity. Now, your question is what you're going to say is you're going to say this has to be less than 1. That's the only difference between power series and the other ones we've been doing. Once you do this, when can I have this side be less than 1? The only time I can have that is when x is 0. And so, remember how we said when L is less than 1, it's convergent? Our L can only be less than 1 when x is 0. So what we say is this is only convergent when x equals 0, right? Because that's the only time we'll have L less than 1. And so now, when we go to the next question, here, can you use power root? No. So you'll have to do your n plus 1 over n plus 1 factorial. And then this goes up top, this goes down bottom. Factorial. This cancels out with this. Well, only the n cancels out with this. So I'll get x n factorial over, rewriting this, I'll get n plus 1 n factorial. This goes, this goes. Now I have x over n plus 1. Now taking my x out of the limit, so if I'm writing it, so write the full limit in the test. They will take your marks, I believe. So, right, take my x out. I'm going to take my x outside, the absolute of it. And then I have 1 over n plus 1. 1 over limit is 0. Now x times 0 less than 1. And so 0 less than 1. And so here, when can L be less than 1? When you put any number for x, you'll get 0. I could put 1,000,000, I get 0. So convergent for all x values. Remember, it doesn't matter what I put for x, I'll get 0. So, right? Here, obviously this is only 1 to the n. This is not to the n, so I can't use root. Again, that's literally how easy it is. Can you use root? No. All right, it's ratio. And so what you'll do is, well, okay, so n, x to the n, so n plus 1, x to the n plus 1, divided by your an, which is nxn. This goes out with this. I got n plus 1 to the x over n. So now what I want to do here, take my x out of the limit. Right, so what I'll get is x absolute, limit as n goes to infinity, n plus 1 over n. Now what can I do here? Remember, divide by your denominator's highest power. And you see this thing goes to 1. This thing goes to 1. Actually, I'll just rewrite it in 2 steps. So this, and then you go absolute of x, limit as n goes to infinity. Here I got n divided by n, which is 1, plus 1 divided by n. Bottom, n divided by n, which is 1. And so now I can take my limit. This goes to 0, so I get 1. And what I actually got is x, 1. And obviously x times 1 is just 1, less than 1. Now the question is, when is my x less than 1, right? And this format, so what you want to reach, when you reach this level and you want to check, if you have, let's say, 3x, you want to take that 3 to the other side. The format you want to be in is x minus a less than r. R is your 1 usually, but if I have a 3 here, well, obviously I'll divide by 3 and divide by 3 to get that format. Now, you see here, in this example, I don't know why I just could have said here. All right, you see in this example, this is actually x minus a, but my a is 0 less than 1. So this does the same thing. And what you'll say is, well, if I put, it's not, okay, so the way you want to think about it is if I put any x value here, will that be less than 1? Well, no. The max I can go for is 0.9999. And then if I increment by 1, that won't work. So what you say is, therefore, convergent at x less than 1. That's about it. Or you can say r equals 1. Same thing. You're basically, when you say these two things, this is saying this. Right? So, anyways, and so this is, yeah, see? And so when the series converge only when x equals a, and so the example where x equals a, you see this? It was 0. And so, well, actually, no, this converges for all x values. Where was a good example? This one. That's x equals a. And so this is when your r equals 1. And here, this is when your r equals infinity. And there is a positive number r. This is when you get some random number r. You know, when you have like a 3 absolute x minus 4, let's say, less than 1. So what we have to do is x minus 4 less than 1 over 3. Take the 3 to the other side. Right, so this is your last condition. Here, you guys have the solutions here. I'll just do it real quick. What, 27 minutes? Okay, we're not too bad. The sum, so we have x minus 2. Can I do this? Root, this is to the n, this is to the n. Cos to the n of 7 over n is the same thing as saying cos 7 over n all to the n. That's the same thing. All right. Oh, look, that worked. That never works for me. All right. So now that I accomplished that this, here, let me go back, remove my arrows. I remove this and obviously put it all to the n. Now my denominator is all to the n, my numerator is all to the n. That means what I can do is x minus 2 divided by cos 7 over n of all to the n. If your whole numerator and your whole denominator is to the n, then that means you could do this whole thing to the n. Remember, when I do 2 over 3, let's say, to the power 2, and you want to apply your square in, you'll get 4. So you'll square the top, which is 4, and you'll square the bottom, which is 9. And so, same thing here. I just raise it all to the n. This is the same as this is to the n, and this is to the n. So I hope that gets the idea across. Now when I got it looking like this, my whole thing is to the n. Use your root to the n. And remember, when we use our root to the n, is basically us saying 1 to the n, and that cancels out with this because n over n is just 1. So that simplifies it by a lot, and that equals cos 7 over n. Take my x over to x minus 2 out, my limit, remember? And so I'll get x minus 2 absolute limit as n goes to infinity of 1 over cos 7n. Now remember, 7 over n, 7 over a very big number goes to 0. Cos of 0 is 1. 1 over 1 is just 1. And so what we get is just x minus 2 less than 1. And you do, therefore, my r equals 1. Or you can say, therefore, my x minus 2 less than 1. Or some shit like this. Now, doing this, is everything to the n? No. So just do, your ratio. And so that'll be 8x minus 3 to the n plus 1 all over, I'll make this long, all over, I have 7 to the n plus 1, and then n plus 1 plus 9, which is just 10 to the 2. Right, now what do you do here? Obviously, bring this up, bring this down. And so here what I'll get is I still have my 7n and n plus 9 to the power 2. In the denominator, I have ax minus 3 to the n. These cancel out with this n. And what else can I cancel out? These, well, this whole thing cancels out with this n. And so what I got here is, well, in the top, I still have 1ax minus 3. And I still have a n plus 9 to the power 2. In the denominator, I have a 7. And I have a n plus 10 to the power 2. Now, if I take these part out, these are constant now. When you have something that doesn't have n, take it out. Right? Because my limit is n to the infinity. See, if it was x, I can't take it out. I can take the n out. But since this is n, I can take the x out. And so this will look like a x minus 3, remember, divided by 7. Limit as n goes to infinity. And I have n plus 9 to the power 2, n plus 10 to the power 2. Now look, these are the same. I can rewrite this as n plus 9 over n plus 10 all to the power 2 and take the limit here. Right? And so now when I do this, what I get is I can divide by n, right? Divide by denominator's highest power. This will go to 1. This will go to 1. Now taking the limit, 9 over infinity, 0, 10 over infinity, 0. So what I got is 1 over 1. Obviously I have this, gotta come here. And this is the limit, is just 1 over 1 squared, so it's just 1, goes away. Now remember, what I got is 8x minus 3 over 7 less than 1. I gotta get the format of x minus a. And so let's do that. Take 7 to the other side. I get 8x minus 3 absolute less than 7. Now I gotta take an 8 out, so I get x minus 3 over 8, and I took an 8 out. Now take the 8 to the other side, I get x minus 3 over 8 less than 7 over 8. And remember, if I go back to our rules, where is it? Well, here you can, for this example, you can just say therefore my x minus 3 over 8 less than 7 over 8. This basically says your graph converges whenever this formula is less than 7 over 8. Or you can say my r equals 7 over 8. You're saying the same thing. Right? Now, quickly, I'm going to go over the workshop questions here. And so, what can I do here? I can take the limit. I don't know if that looks like that. Let's take this page out. Go. All right, so here we have in, in ln. Now, actually here, let me limit as n goes to infinity. I have ln of n over 3n plus 1. Can I take the limit of this? Yes. Divide by the denominator's highest power. This goes to 1. This cancels out. This goes to 0. 1 over infinity, 0. So I got ln 1 over 3. Now, which one did I use here? I didn't use root. I didn't use ratio. I just took the limit normally, really. So it's pretty easy. And so ln of 1 over 3, is that less than 1? Let's check. Ln 1 over 3 is negative 1.0, less than 1. And to be honest, with this one, I remember doing it. How did I do it? Lol, can't remember. I believe there was one more way you could do it. How far back can I go? I guess not. To be honest, I'm not sure of this one. You'll have to confirm it on your own time. Sorry about that. I got negative 1. I'm pretty sure I took my limit fine of 1 over 3. I'm just not sure about this statement. So we'll have to confirm this statement right here. Okay, here, this is raised to the n. This is raised to the n. So I could rewrite this as n2 over 1 plus 2n2 all to the n, right? Now I can do my 1 over n, cancel both these out. That's my root rule. And so after these cancel out, this is what I got left with, right? And so now when I have this, divide by the denominator's highest power. This goes to 1. This just cancels out. This goes to 0. So I got 1 over 2. Less than 1? Yes. Therefore, this converges. Same thing here. Now, how do you notice it's a series, by the way? How do you notice it's a power series? It's when you have x, and we'll go through it in a bit, actually. And so we finish this one. This one, you see, this is to the n, this is to the n, but this is not to the n. So you can't use root, you'll have to use ratio. And so this is -5, 2. Remember, this is n plus 1. Don't just do this plus 1. That's not the same. All right? Divided by n plus 1 squared, and then 9n plus 1. Remember, bring your top up, bring your top down, and now this is what we get. What can I do here? Let me rewrite it more clean. This becomes 2n plus 2. And I got n to the 2, was it? N to the 2. 9n all over n plus 1 squared 9n plus 1 -5 2n. And so what you can do here, well, this n cancels out with this. This 2 cancels out with these 2n. And so what I got is -5 squared n squared all over n plus 1 squared. Now obviously I'm taking the limit here. I can take the constant out. Remember, constants always go out. And so I can take that out. That goes out of the way. I forgot something. Oh, I have a 9 here. I forgot that. See, there's a 9 here. There's 1 left. So don't make the mistake I just did. There's a 9 in the denominator. I can take that 9 out as well. This is what I have left. Now, this becomes negative. Well, I'm taking the absolute, remember? And so this negative doesn't do shit. So what I got is 25 over 9 now. I took my square root. And so what I get is the limit as n goes to infinity. Now you see this squared, I can rewrite this as n over n plus 1 all squared. Now divide by n, divide by n, divide by n. This goes to 1, this goes to 1. 1 over infinity, 0. That's 1 over 1 squared, which is just that. And now what I got here is 25 over 9. That's less than 1. Is that less than 1? No. Therefore, diverges. Okay? This one more example here. To the n, to the n. Can I write this somehow so that it's to the n? Let's see. Oh, wait. Only the 3 to the n here. This thing is not to the n. So I can't even use root here. So that's ratio. Let's do ratio on here. Again, it's so simple. 1, n plus 1. Here, this is already n plus 1. Plus 1, you get n plus 2. I have 3 n plus 1 all over. And make sure you keep this long, because you still have more things coming on top of this. This is 2n plus 1 plus 1. That's how it looks like. You want to take whatever your n is and add the plus 1 in here. All right? And so what does this look like? This looks like 2n plus 2 plus 1, remember? Boil this in. And so what I'll get is 2n plus 3. And so this will become 2, and then 2n plus 3. Now, bring this down, bring this up. Oh, sorry, this is 2n plus 1. And here I get -1 n, and then n plus 1, 3n. And so when you're doing this, cancel things out. This goes with this n. Then I'll get -1. I'm taking the absolute. The whole thing goes away. I'm missing here. Oh, I'm missing the 3n. And you see now 3n cancels out with this n. I get a 3 on top. What else here? This 2n cancels out with this 2n. I have 3 minus 1. That becomes a 2. And that thing goes away. Now I got these two. I'm going to just leave them as is for now. So I have limit as n goes to infinity. What do I have? 3. Well, 3 is gone. This whole thing's... Is it? No, sorry. There's a 3 at the top. 3 at the top. I have n plus 2. At the bottom, I have a 4. 2 squared, 4. N plus 1 to the 3n. Where did I get this 3n from? Oh, that was this 3n. Okay, there you go. And so now, n to infinity, I can FOIL. Right? Now I can divide by n. Divide by n, divide by n. 6 divided by infinity, 0. 4 divided by infinity, 0. These two n's cancel out, and these two n's cancel out. I'll get 3 over 4. Is that less than 1? Yes. Converges. That's really about it. That is how simple it is. Now there is one more for power. It's right here. There you go. And so now this same thing. Can you do root or can you do power series? Sorry, not power. Ratio. I can't do root. I can do ratio. So this is n plus 1 squared x to n plus 1. Remember, this is 2n, so I made the same mistake. This is 2n plus 1 all over n plus 1 factorial. Rewriting this, what I'll get is n plus 1 squared x. So this is x to the 2n plus 1. Plus 2 all over. Oh, I forgot one part. Remember, bring this up, bring this down. That's what I'm gonna do. I'm just rewriting it anyway, so that's fine. Here I have n plus 1. Remember, your n plus 1 factorial is also written as n factorial like this. These are equivalent. And here, bring my down up, so this will have an n factorial. Bring this part down. N squared x to n. Now this x to n will cancel out with this to n. This factorial cancels out with this factorial. What do I have left here? I have n plus 1 all squared to the x squared all over n plus 1 n squared. Now, what can I do here? I can take my x out, right? I can take my x outside. And so, did I put this in wrong? No, that looks pretty right. Okay, so now I can take my x out of my limit, so I get x squared absolute. There you go. Now what this becomes, what I can do here is I can FOIL this. I'll get n to the 3 plus n squared. And at the top, yeah, I could do that too. And so here, when I take it, so I got, I'm gonna FOIL this out. Right, and I'm gonna FOIL this in as well. So what I got is n cubed plus n squared. FOILing this top out will become n squared plus 2n plus 1 all over n cubed plus n squared. Remember, divide by the denominator's higher power. Right? And so what will happen here, this will cancel out, become 1 over n, which goes to 0. So this whole thing goes to 0. This will cancel out. I'll get 2 over n squared goes to 0. 1 over n cubed goes to 0. This will be 1 over n goes to 0. And this will go to 1. So what you got is actually 0 over 1, which is just 0. Now I got x squared times 0 less than 1. So what you want to ask is, for what values can I put x to be less than 1? Well, you can put any x. You'll times it always by 0. And so this will always go less than 1. And so this converges for all x values. Right? I only got 3 more. Let's do them. And so here, this is to the n, but this is not to the n. So ratio again. Thinking, yeah, you see, like this is root. What I can do here is do the root, so all these will cancel out. This will cancel out. This will cancel out. This will cancel out. This will cancel out when you do your root. And obviously, we're taking the absolute, so this whole thing will go away. And so what you get is x minus 1. You'll get n over 3. Take your limit. My x minus 1 I can take outside, absolute. And I can also take my divide by 3 out. I'll only have an n left. This goes to infinity. So now this is what I have. X minus 1 over 3 times infinity less than 1. What can I put for my x for it to be less than 1? If I put a positive 1, I'll get 1 minus 1 over 3 times infinity. 1 minus 1 is 0. 0 divided by 3 is 0. 0 times infinity is 0. That's less than 1. So, invergent 1 x equals 1, right? And so here, this is again your other rule that we already been through. Your, what is it called? Ratio. And so if you want to do this, you got to do plus 1 here. You'll do plus 1 here to the power 2. So what you do is just n plus 1 to the power 2. You bring your top down, you get 3x plus 1 to the n divided by the top. You'll get 3x plus 1 to the n plus 1. And then you'll also get your denominator, which is n squared. Now when you do this, this will cancel out with this n. And then what you get is 3x plus 1. Then you get n plus 1 squared, n squared. You can take this out your limit, right? So you'll get 3x plus 1 absolute. And then you get n squared over n plus 1 squared. So I can rewrite this as n plus 1 all squared. Obviously, divide by n, divide by n, divide by n. This goes to 1, this goes to 1, this goes to 0. You get 1 over 1, so this whole thing just goes to 1. This is what you get. Obviously, this is not in the format of this. And so what you do is pull out 3. Right? Now take 3 to the other side. 1. 1 over 3. Now I'm not sure. You guys will have to confirm this. I'm not sure for this either. If this was a plus, remember how it's x minus 1 they want? You also pull out a negative, then you divide by negative, so this becomes a negative. And like, so it becomes like this. I'm not too sure about this part, so you guys will have to confirm that off Google or something. And that's about it for this. Thank you guys for watching.